This lesson involves triangle congruence, the angle-side angle and angle-angle-side postulates. In your workbook on page 77, and it's lesson 4-3. Our Common Core standards are to prove theorems about lines and angles, and specifically our objectives to compare and analyze triangles by their structures to determine and prove that they are congruent. You, at the end of this lesson, should be able to determine if two triangles are congruent by applying theorems of congruency. Here we go. On page 77, we have two postulates, well, one postulate and one theorem that we have to look at. The first postulate is 4-3, angle-side angle, and it states that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent, and this is by the angle-side angle postulate, which is abbreviated as ASA. So therefore, triangle HGB and triangle NKP are congruent. The next part is a theorem, theorem 4-2, which is the angle-angle-side theorem, states that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are also congruent, so CDM and XGT. Let's take a look at that for just 1 second. So we have two angles here, and not the side in between them, but the side after them. That's the angle-angle-side theorem. Let's take a look at some examples. Here's using angle-side angle. So we want to suppose for a second that angle F, the one that's not marked here, is congruent to angle C, and angle I is not congruent to angle C. So neither one of these two angles are marked, but we're saying that F is the one that is congruent to C. And so, therefore, the diagram shows that angle N, right here, is congruent to angle A, which is also congruent to angle D. Notice their double arc markings. So, if angle F is congruent to angle C, then angle F is congruent to angle C, and it's also congruent to angle G. So, therefore, FNI and CAT and GDO are all congruent by the angle-side angle theorem. Do the quick check on the bottom of page 77 to see if you can figure this out, then come on back in just a second to find out whether you're right. Moving on. Using only the information in the diagram, can you conclude that INF is congruent to either of the other two triangles? You can't. With the information given, you cannot, because all we have are a side and an angle. So we need either another side, another angle, something like that to be able to figure out one or the other of those postulates or theorems. Back to the examples now. This is writing a proof using angle-side angle. They want to write a paragraph proof, which is a type of proof. Here's what we're given, that angle A is congruent to angle B, that's shown right here in the chart, and that side AP is congruent to BP, so AP congruent to BP. By the way, that also makes point P here a bisector. So we're being given that A is congruent to B, and that AP is congruent to BP. APX is congruent to BPY because, well, these two are vertical angles here. So it's the vertical angles theorem. And because two pairs of corresponding angles and their included sides are congruent, so I got this angle, this side, and this angle on both triangles, that means that they are congruent by angle-side angle. This is about planning a proof, and then the next one will be to actually write the proof. So we want to write a plan for a proof that uses angle-angle-side. Here are the things that we're given in here. Angle B congruent to angle D, and side AB is parallel to side CD. We want to prove that ABC is congruent to CDA. So this one congruent to this one. So because side AB is parallel to side CD, and there's the markings that tell us that they're parallel, That means that angle BAC right here, will be congruent to this angle down here, which is DCA. And that's because they are alternate interior angles. Remember, we've got two parallel lines cut by a transversal, AB, DC, cut by a transversal. Now, even though this line does not extend beyond this parallelogram, it's assumed that it could and that it would. So that is a transversal. So therefore, this angle down here is congruent to this angle here, and it's by the alternate interior angles theorem. So therefore, ABC is congruent to CDA if a pair of corresponding sides are also congruent, because we've got an angle, and then if we can have this side right here, then that would be it, and we do have that side because AC is congruent to itself. That's the reflexive property. So therefore, ABC congruent to CDA by the angle side theorem. Let's write this out now as a two-column proof. Same information given, angle B congruent to angle D, AB is parallel to CD. So here's where we put these things into the proof. The first part, well, this is all given, so we write given in there. And then the second part we get is that angle BAC is congruent to DCA, and that's because they're alternate interior angles, and those are congruent. AC congruent to AC because of the reflexive property of congruence. So therefore, triangle ABC is congruent to triangle CDA, and that's by the angle side theorem. All this information we gleaned from the planning process from the previous example. So now, would you do the quick check on the bottom of page 79? After you've taken your shot at them, come on back and we'll check and see if your answers are in fact correct. Here we go, quick check number 2. Write a proof. Here's what we're given. NM is congruent to NP. That, of course, makes N a bisector. Angle M congruent to angle P. It's also given. So we want to prove that NML, this triangle here, is congruent to NPO, this triangle over here. And we have a lot of different things that we can choose from to be able to make that happen. Well, since it's given that NM is congruent to NP and M is congruent to P, that means that MNL is congruent to PNO because vertical angles are congruent. So these two right here are congruent because they're vertical angles. So therefore, we have an angle, a side, and an angle. We can prove that these two are in fact congruent by angle, side, angle. Next up, a flow proof. Don't see these too often, but they do in fact exist and they work pretty well. We've got RP bisecting SRQ. That's what's given. And so from that, we can assume that angle SRP is congruent to QRP, and that's because those are the definitions of angle bisectors. Continuing, we know that RP is congruent to RP, and that's from the reflexive property of congruence. And then over here, angle S is congruent to angle Q. That's also given back here in our information. So because of that, we can conclude that the two triangles are in fact congruent, and that's because of angle, side. Now we want to take a look back at example number 4 and explain how you can prove that ABC is congruent to CDA using angle, side, angle. Remember, in the first time we wrote a two-column proof with angle, side. Not going to do that this time. It's going to be angle, side, angle. So yeah, you can attack these things in different ways sometimes. So we're given that B is congruent to D and that AB is parallel to CD. So we're going to use a lot of the information that we used from previous there, but this time we want to prove angle, side. So we've got those two angles are in fact congruent. So we have BAC and DCA, and that's because they are alternate interior angles. And we also have that BCA and DAC are congruent, and it's the same deal because they are alternate interior angles. So look what we have. We have an angle, we have a side, reflexive property again, AC is congruent to AC, and we have another angle. So we can prove it using angle side angle. Here's what we might write. So, here are our objectives. Compare and analyze triangles by their structures to determine and prove that they are congruent. At this point, hopefully, you can determine if two triangles are congruent by applying theorems of congruency.